In this lecture, we will study improper integral using Python, mainly NumPy and SciPy packages. Before going to that, we just give a brief primer what the improper integral is. Integration from a to b fx dx is said to be a improper integral if it is integrated over the unbound interval. That means either a is infinity or b in infinity or both is infinity. It may be minus infinity to plus infinity or plus infinity to minus infinity, whatever, and it might happen the integrand, that means fx is divergent or infinite within the interval of integration, or at the boundary value. That means suppose at the integrand is infinite or diverges or blows up at the boundary value either a or b, or within the interval of limit of integration. Just give an example in order to facilitate the understanding. Just supposed to be the integration from a to infinity. Here first the function is supposed to be at infinity. That means it is a improper integral. It might so have an fx is such that within the limit of integration, then maybe the fx blows up. Then it's also the indication of the improper integral. Supposed to be the integration from 0 to infinity 1 over x dx. At x equals to 0, at the 0 value, the integration blows up. Also the integration extended up to infinity. That's why it is unbounded interval and diverges at some boundary value of the limit. So that's why it is an improper integral. And 0 to 1 over root of 1 minus x squared dx. Here at x equals to 1, at the boundary, one of the boundary, it blows up. That's why it is an improper integral. And if we do the integration from 0 to infinity 1 over x squared dx, and in the one of the limit x goes to 0 or x equals to 0, it blows up and also it extends up to infinity. It's an improper integral. How to tackle this kind of integration? Supposed to be in from I want to integrate from 0 to infinity fx dx and limit. Then we do the integration from 0 to a, and after evaluating this integration, and we take the limiting operation, and from where a goes to infinity. If this limit exists, then the particular value will be the value of the improper integral. If the limit does not exist, then we cannot evaluate that improper integral in that way. And there must be borne in mind, in order to exist, in order to have a value of the improper integral, supposed to be minus infinity to plus infinity fx dx, fx must be divergent. That means fx must goes to 0 as x goes to plus minus infinity. That is a hand waving argument, and it is not easy to see which function will give the definite value of this improper integral. Just in our physics course, we will just give some examples of improper integral. These are the examples of improper integral supposed to be, and these are the examples supposed to be. I want to integrate from 1 to infinity of the function 1 over x dx, and I am making this a finite one, 1 to m 1 over x dx, and then take the limit m tends to infinity. That means rather, and limit m tends to infinity, and 1 over x dx is log m. That means log m minus log 1, and log 1 is 0, natural logarithm 1 of 0, and logarithmic function is always increasing. This kind of function, as m is increasing, that means m goes to infinity, diverges. Therefore the 1 over x dx does not have any this kind of improper integral does not have any fixed value or value. That means the area under this curve, no finite value exists. The integration means the area under this curve, that means no finite value exists. Now I'm making the faster rate of decay of this function fx, that means 1 over x squared. And what happens to that function? 1 to infinity 1 over x squared dx. And just the recipe is same, limit m tends to infinity 1 to m 1 over x squared dx. That means limit m tends to infinity, and the integration of these things is 1 over minus 1 by x 1 to m, and we put the limit 1 over m plus minus plus 1, and that becomes 1 minus 1 by m, and limit m tends to infinity, this becomes 1. That's a finite value. That means the integration 1 to infinity 1 over x squared dx converges to 1. And numerically, how to handle this kind of improper integral? Basically, we just convert it into a finite one, minus m to plus m, and making m gradually larger and larger, so that the value of the integrand doesn't changes appreciably within the limits of our numerical calculation. Supposed to be I am giving 3 decimal, 4 decimal, or 5 decimal places. If we adding more values, that means we are increasing m, then there is no appreciable change within the limits of accuracy, then we can say that is convergent. Value of this limit is convergent. Integration does not change appreciably. That is the point. Now I give some review of the trapezoidal methods and some methods, and this is basically in order to understand how to calculate or how to compute numerically the improper integral. That's the crucial inputs that is not actually needed, but give some idea before going to do any use any packages. You just give the you must have some idea of what is happening inside this. I think you already familiar with trapezoidal methods. Here area is approximated. This is a curve fx. This is the function fx, white color line, and we approximate, supposed to be I just making it a segments, that is first 1 2 3 4 dot n, and this is the point a, and this is the end point is supposed to be function end point is b, and which is denoted as xn, and the initial point is x0, x1, x2 dot. We divide the whole segment, the integration a to b fx dx and whole segment a to b into a n equal subintervals, right? And we connect these 2 points by a straight line, and this is a trapezoidal, and what is the area of this trapezoidal? Half times f of x0 and f of x1 times this is the base distance, this is the base, and that means distance between 2 parallel lines, and this becomes h, as is evident from here. And if we do the integration, if we do the total area under these zigzag lines, not the actual fx, it is an approximation, you know, and half of, and this thing becomes half of x1, and not half of times fx1 plus fx2 times h, and this way, and up to n half times f xn minus 1 plus fx times. And if we I'm just giving a brief primer, that's why I'm just skipping many parts, and that means it becomes h over 2 if the first value and last value, that means this is basically a, and xn is this basically b, and the rest of the values are there, the intermediate values. This is a closed type. This is a closed type of formula because in these numerical methods it includes the endpoints, that means a and b, while doing the integration. That's the main point you should bear in mind. It involves the endpoint. This is a closed type, that is called closed type. Simpson-Walton rule is also same kind of thing. Basically here approximating the integrand by the second order polynomial, that means fx equals to a0 plus a1x plus a2x square. I am not giving the complete derivation, I am just stating the results, and I am not giving the detailed derivation here. And it turns out that it can be approximated in this way: h over 3, the first value fa, and 4 times the intermediate value. It is a one segment formula, and 4 times f a plus b by 2 plus fb, if we consider the one segment a and b. And if we in the previous just like the previous case, if we divide the interval a and b into n equal intervals, then h can be written as b minus a by n. And if we use this Simpson's approximation, this kind of in every segments, that means each segments, and if we adding all this up, and you will get this formula b minus a divided by 3n, the second bracket f x naught, which is the first value, and 4 times sum over all fxi on summing over odd values and summing over even values fxi and the last value fxn. That means it is also a closed type formula. That means you need to compute the n values. That means supposed to be in our improper integral is infinity. That is very tough to do calculation. We have to add infinitum. Supposed to be the integration. That is not whenever the infinite. That means you have to adding more terms and more terms in this formula. And you have to check the convergence. That means the while you adding the terms, and you have to check after summing n terms and after summing n minus, so what is the change. If the change is or the fractional change final minus that means tn minus 1 divided by tn, whatever way, you just calculate the accuracy increased after adding terms, and you can discard it after that. The numerical game, you just discard the numerical game. And this is a closed type, means here involves the n first points, at least if a is 0, that if the function fx itself is kind of divergent behavior or blows up at the boundary points, then it is very hard to do in this case trapezoidal method or Simpson method, because it always involves n. When you have to start from slightly different value from that value, you have to approach that value in a limiting way. Rather, and there is another method that is a very famous method, is the Gaussian Quadrature. I am not giving the every details of Gaussian Quadrature, and you have to. I think you are already familiar with in the previous semester. In the previous semester, there is a course on integration and how to do that integration in an involved way. I am just giving the brief primer, and as I have already said in the beginning of the lecture. In order to grasp the idea behind Gaussian Quadrature, we try to develop 2-point Gaussian Quadrature rule. And here the function fx dx can be approximated as a supposed to be as a polynomial. I am just giving this kind of thing. Supposed to be, I am computed the function at some value c1 times fx1 plus c2 times fx2 and x1 x2, the point within the interval of integration. Here just I am approximating this the whole integration, something like this, where c1 x1 c2 x2 are unknowns, and the integrating function, that means integrand, is approximated as a third order polynomial. Third order, this is supposed to be gives the exact result. Suppose I am fx is a third order polynomial, and which gives the exact result whenever I am writing in terms of c1 fx1 and c2 fx2. And if we do the integration fx dx, and I am approximating the integrand as a third order polynomial, that means a0 x, a sub 1 x, a2, a subscript 2 x square, and a subscript 3 x cube dx. And if we integrate this, and you will get this thing a0 a, sorry, this is not a0, it is a times b minus a. And this is a0 here, this thing b minus a1 a2, and this thing, and this can be written, and if you just do the calculation, you will get this thing. And I'm sorry, just this is another thing, just skip this part, and we know, and fx dx is c1 fx1 c2 fx2. And I am putting fx1 as a polynomial, third order polynomial, that means a0 a1 x1 a2 x1 square a cube x1 cube, and c2 a0 a1 x2 a2 x2 square and a3 x cube. And if you compare this thing and this thing, and you compare 1 and 2, what happens? And if you comparing the powers, and you will get 4 nonlinear simultaneous equation. B minus a equals to c1 plus c2, b square minus a square by 2 is c1 x1 c2 x2. And I hope you will calculate this thing in your homework. As a homework, you calculate this b cube minus a cube by 3 is c1 x1 square c2 x2 square, and b to the power 4 minus a to the power 4 minus 4, this thing. And it can be shown the 4 simultaneous nonlinear equation have only one acceptable solution, and C1 can be written as B1 minus A by 2, and C2 can be written as B minus A by 2, and X1 this thing, and this is the, and C1 C2 X1 X2, and this can be written in this way. This is the solution of the C1 C2 X1 X2, and we can say the integration according to Gaussian quadrature is a 2.1. If we think about this, fx dx can be written as C1 evaluating this function at the point x1, which is evaluated this way, and this is x2 and evaluated this one, which is not the boundary itself. It is a combination of these things. It is not a boundary at all. Therefore, whenever you just computing this integrand, you just C1, there is no boundary value, and f x1 plus C2 f x2, and x1 x2 is not a boundary value. It is the intermediate points of which is calculated in this way. And there is a Gauss legendary or and is a complex thing. There are so many different ways of approximating the function, polynomial function, Gauss legendary polynomial or others, and you can check in a standard numerical textbooks. But my main point is the Gaussian quadrature never involves the boundary values while integrating or approximating the integrations. So therefore it is very useful while handling improper integral. And basically scipy function, quad function usually implement the Gaussian quadrature, and we will go to the scipy package. Now we use how to use scipy quad function, Trapz function, and Simps function. Now we go to, and we already know this is import NumPy as NP. Import import NumPy as NP and import scipy.integrate as SCI, and this is calling scipy packages, and f equals to lambda x, where the very simple function x square. How to integrate this SCI.quad, and if you enter this and if you hit the run, that means x cubed by 3, and this is basically this value, and this is the error of this integration. This is very small. Suppose I am just giving a very simple example, lambda x, and this is basically x square by 2, and from 0 to 1 this is the limit of integration, and this is the function itself, is a lambda function. This SCI.quad, if 0 to 1, that means half, this gives the half, and this is the error. This is the use of quad function. I encourage you to see always the scipy.org, docs.scipy.org website. There is every details of scipy integration functions, different integration functions. You will get there here. This is a very extensive documentations how to integrate scipy.integrate package. There are in the scipy.integrate package quad function, double quad, dbl quad, in order to integrate the double integral, triple integral, and over multiple variables, fixed quad, fixed order Gaussian quadrature. Definite, there are some different methods, and you just go through this and you will get a better idea how to calculate. And I am not giving the details of quad functions, and while using you will understand something. And in order to integrate, there is a famous function that is exponential minus x square, and you know the result, that is basically square root of pi. And basically it is, if we integrate from minus infinity to plus infinity, that means I want to integrate minus infinity to plus infinity, just giving you that that means minus infinity to plus infinity to minus e to the power x square, that is always root of pi. That I check from scipy packages, that is basically lambda x np e to the power x square psi quad f. This is the lower limit, and you can give the infinity in this way using NumPy package minus np.inf plus np. It is a very large number, and it gives 1.7222 24538509055 and if you print the square root of pi, that is basically this, and you just astonishing result. This gives a quad function. Is a very useful thing to calculate. This is basically a improper integral. Now I want to integrate supposed to be 1 over and I am just giving the error here. Okay, just 1 over x. First we integrate 1 over x rather, and what happens? This is basically psi quad. Just check it. This is a error, and why this error comes maximum, because you cannot, we know from our calculations 1 over x is a divergent thing, and it gives integer warning. Maximum number of subdivision 50 has been achieved. Increasing the limit yields no improvement. That means there is no convergence. It is advisable to analyze the integrand, as we have said in our theory part, in order to determine the difficulties. If the position of a local difficulty can be determined, singularity, discontinuity, one will probably gain from splitting up the interval and calling the integrator on the subranges. Perhaps the special purpose of integrator should be used. Warning, message integration warning. Now if we give so you want to finite, supposed to be 1 to 2. Suppose I want to integrate from 1 to 2. What happens? It gives some results. But whenever you give infinity, because it's divergent, the integrand is a divergent. You always, in order to integrate something, it must be convergent one. It should be borne in mind, and it is here. It is divergent, so that's why it cannot calculate up to infinity. Well, now I go to the how to calculate supposed to be 1 over x square. That is very important function. It is a 1 over x square is a convergent one, and 1 to infinity, that means np dot inf 1 over x square dx from our theory. What is the result here? Just giving us a check. 1 to infinity 1 over x square dx, that is 1, and it matches with our NumPy results. And if it is 0, then there is a and if it is 0, it calculates something, and there is a, and you check what happens to other ways of calculating. Supposed to be in order to the same thing we want to calculate in a trapezoidal and Simpson methods. I have to create a array of x and y, and array is a 1 to is a large value. I want to integrate infinity. I am thinking of a very large value. I rather first from 1 to infinity. I am creating a large value, that means something large, and it's a very fine division, and y is something 1 over x square, and trapezoidal and Simpsons I want to print both. Print both of them. .029, and that is according to Simpson's rule. That is trapezoidal rule, and that is Simpson rule, and from it is from 1 to very large value, and if you making it more larger and larger, and you will get something like that. There is some error, because you just I'm not giving the reason. You just check it out, and what happens to that is your home task. If we integrate from if lambda function 1 over x, lambda x 1 over x square from 0 to infinity, that is basically this value. There is a minus sign basically here, gives the result basically. And if we want to integrate from our aim is to integrate from 1 to infinity, and this is basically 1, and if we want to integrate using trapezoidal Simpson, 1 is a large value, and it divided in these things, basically this kind of thing. this result is, I think, the wrong result. And if we increase this, the number of points, then it becomes 1. And you play around these things. And but here, if we make it 0, what happens to this? And this is basically point minus 0.99999 something. And if we make it 0 here for in Simpson and trapezoidal rule, and this becomes infinity, because there is a 0 division error encountered, because, and if you just slightly different from 0, and then it, I think, it work, but it's a wrong thing. And you just make little bit larger. This is also not a good thing. This is not a good thing. And this something, this is also not giving you any results. No results. And that is the something, the trapezoidal and Simpson root, that is the way. And if we try to play around these things, what happens to here? This is not a good one. This is not also thing, and that is the main way. And if there is a at the boundary value, if there is a singularity at the boundary value, then trapezoidal and Simpson root does not work very well. And giving more example and why there is a minus sign, that should you think about this thing. And now we go to square root of x, 0 to 1, and if we want quad, and then there is a something. Oh, that is the error, because it should be np here. Np, there should be np here. Square root of x. Square root of x, that is squared, that is almost 2. And if you use this thing, and then also that thing happens 0 to 1, if you integrate from 0 to 1, and now check, and this gives some results, almost 2. And this is very it is, if it is 0, and if it is 0, then there is 0 division error, and if you make it a very small quantity, then it works. I think this sometimes it works, and if you slightly displace the boundary value divergences. Now you go to 1 minus x square, square root of 1 minus x square, 1 by 1 minus square from 0 to 1. What happens to this? You just play around these things, and using trapezoidal and Simpson rule, and where there is a singularity at x equals to 1, and whenever I'm just creating a array from 0 to 0.99999, and divided, that limit is a very large, 10 1 0 0 this thing, and makes a array of ys, and calculate x's and y's, and if I supposed to be, this is supposed to be, I'm just copy it, cut it, and it make it 1. What happens to the result? There is a 0 division error, and making this thing, this is something 1.57, and you already know the result is pi by 2 in this case, and this is basically the result. In this case, somehow you manage this by tweaking the boundary thing. And this is a famous gamma function. If you integrate this, I am not giving explanation, you just check it out. And also I am giving here a boundary, a transformation here, and np e to the minus x fx d x to the power n minus 1, and I'm giving a transformation here. And what kind of transformation? Making the infinity removed here, and just give to the notebooks. And this sort of transformation, making for finite domain, we can turn this into a finite domain, and we can making this a finite domain thing. Well, I just think about this, and if we do the transformation y equals to 1 over x, 1 by 1 plus x, that is equals to x equals to 1 by y minus y, and dx equals to dx equals to something mishap happens here. This is not y here, and this should have been dx equals to some misplaced here, that is minus 1 over y squared dy, and that is misplaced, that should be here. And x equals to 0 and y equals to 1, and x equals to infinity, y equals to 0. And if you getting back to here, and if you put x equals to minus 1 over y minus 1, 1 over y minus 1 y squared dy, and changing the limit of integration, that should be the 0 here, and it comes here. And this now I integrate 0 to infinity becomes 0 to 1. That is done here in our notebook, Jupyter notebook. I am calculating this thing also, and np 1 minus 1 minus x, 1 minus x to the power n minus 1, 1 by x square, and integrating from 0 to infinity this thing, and 0 to 1. Argument is half, and gamma half is, and square root of pi. The same result, almost same result. And if you 3 by 2 is this thing, and the result is gamma half is root pi, here I calculate. And if you calculate using trapezoidal and Simpson's rule, you have to change the limit, because in the 0 value there is a 0 division error, I think happens. There is a 0 division, 0 division error. I am making it a smaller change from 0, and it gives almost the same value. It is a gamma, I think, and if n equals to 1 and is supposed to be n equals to half, what happens? Let's check it. There is something wrong, and that is the main problem with trapezoidal and Simpson rule. You just play around this thing, and you will get definitely so many exotic things out of this. And that is quad function is a very useful while calculating the improper integral.